part 2 of isotopes. How do we name them? Well, we've already seen that you can write the symbol with the atomic number and the mass over to the left, but we can also use the words and actually this time put the mass number after the name of the element. For example, carbon 12. That 12 is the mass number. Remember, carbon has protons of 6, not 12. Carbon 14, uranium-235. Okay, remember, isotopes are atoms of the same element, but they have different masses due to the varying numbers of neutrons. So same protons, different number of neutrons. Notice I haven't talked about electrons, and that's because they really don't play a part in an isotope. Okay, so here's an example of a same element but different isotopes. We have hydrogen 1, also called protonium. Notice they all have protons numbers of 1, which means their atomic number is 1. The first one, hydrogen 1, has 1 electron, no neutrons. Hydrogen 2, which is deuterium, 1 proton, 1 electron, 1 neutron. Hydrogen 3, tritium, which is 1 proton, 1 electron, 2 neutrons. So this is what it would look like. Here's the nucleus. It only has the 1 proton in it, no neutrons. So this next one should have 1 proton and 1 neutron. The orange is representing the neutron. And remember, they're same sizes, of roughly 1 AMU. So let's do a predict. Hydrogen 3, or tritium. How many protons? 1, good. How many neutrons? 2, good. So you should have something along the lines of that. Alright, isotopes, basically elements that occur in nature are mixtures of isotopes, which means there are a lot of different ones. For example, carbon 12, there's carbon 14 out there. There's a bunch of them. So for example, this is showing it again, just so you can see them. Here's helium. We've done the hydrogen, so let's skip down to the helium. Remember, right here's your mass. And remember, the mass is mostly going to be because of that nucleus. Remember, those electrons are super small, so they really don't figure into the mass of any element. So this 3 represents 2 protons plus 1 neutron, that's 3. 4 would be 4 neutrons, 4 positive. Lithium, which has an atomic number of 3, same thing. Here's lithium 6 and lithium 7. Alright, so let's start figuring out how we figure out the atomic mass on the periodic table. Exactly how heavy is an atom of oxygen? Well, it depends, because there are different kinds of oxygens due to those different numbers of neutrons. What we get more concerned with is actually the average atomic mass. On your periodic table of elements, that is what is listed, is the average atomic mass. And this is basically how we're going to calculate it. It's all based off of percentages on how many there are in nature of that element with that isotopic amount. Because it's so small, obviously we don't use grams, we use atomic mass unit, AMU. It is defined basically 1/12 of the mass of a carbon 12 atom. And what that means is carbon 12 was chosen because of its isotope purity, which means how pure it is. It doesn't have a lot of extra things in it. And each isotope has its own mass. So then we have to determine the average based off of the percentage it is in nature. So this looks a little bit more complex. We won't do very many of these, so just have a working knowledge of it. To calculate the average, you're going to multiply the atomic mass of each isotope by its abundance, that's percentage, and you're going to convert that to a decimal, then add them together like you do any other average, and then go from there. If you're not told any different, assume that it's measured in AMUs. So since your mass is the average of all naturally occurring ones, this is kind of how it would look. We have carbon 12. It's actually the most popular out in nature. Notice, look, It's 98.89% of all the carbons in nature. Carbon-12 is the most abundant, followed by carbon-13 with 1.11, and then we have less than 0.01 of carbon-14. So which one do you think is the most? Well, look at the percent in nature. So if you look on your periodic table of elements, you'll notice that underneath that one, it actually has its carbon as 12 AMUs. And that's what it is here. Oftentimes it will be rounded. So the mass you see on your periodic table is actually representing the isotope of carbon-12, since it's the most. And here's one other practice problem for you to see. We're not going to work it out. It's more complex, but I did want you to become aware of it because we may do some in class. All right, that finishes up isotopes.